Intervals of monotonicity, which basically just means going up, going down, or constant. Something that you really better pay attention to. Really, really important. First thing is, always read a graph left to right, no matter what. Also, we're only going to use x values for this. Intervals of x, intervals of x, intervals of x. And also, we're always going to use parentheses, so keep that in mind. So, when we read left to right, if the graph goes up, I'm going to use the up arrow a lot of times to represent increasing. That's where it increases. If it goes down, down arrow means it's decreasing. If you see this constant arrow, it's a constant. So it doesn't go up or down. So let's just do some examples so you can see exactly what's going on. So, if you notice on this, I'm going to draw some arrows just so you can better see it. And then the next example, there won't be any arrows, which may be even easier to see. From the left, we're coming from way over here. This is actually negative infinity. From the left, it's going down. And then from here to here, it's going back up. Notice it's going up. And then from here, all the way from here to positive infinity, it's going back down again. See that? Down. So we got intervals where it's increasing and intervals where it's decreasing. Now before I do anything, I like to label these points. This point is 0, negative 8, and this point is 2, 0. Once again, since I'm only doing intervals of x values, I don't need the negative 8 and I don't need that 0. I'm only using x values. So I'm coming from negative infinity, and the curve is going down to not to negative 8, because we're not using the x value, we're using 0 because we're going left to right. So from here to here, it's going down. So from negative infinity to 0, it's going down. Now from 0 to 2, curve is going back up. And then from 2 to infinity that way, it's going back down. So that's a decrease. Since I have two intervals of decrease, to connect them I use a union symbol. So once again, I'm never using the y values on this increase and decrease. It's always the x values. So really easy to make that mistake. In fact, once you get the hang of it, that's the only way you'll make the mistake. So now I'm going to do this one, and I'm not going to do all those arrows. We're just going to read left to right. From the left, we know what's going. Looks like it's going down, and then constant, and then back up. So we got 3 of those. So from negative infinity, it's going down. It's going down until we get the x value of negative 2. So that's negative infinity to negative 2. And then from negative 2 to positive 2, these points were already labeled for me, so I don't have to label them. From negative 2 to 2, it's a constant. This is an interval, it's not a point, it's an interval. And then from 2 to positive infinity, it's always going back up. 2 to infinity. And that's it. Now the reason why we use parentheses is because from at negative 2, it's changing. It's not going down, and it's going constant from there. So what would you put at negative 2? Would it be decreasing or would it be constant? Well, it's actually neither. It's changing direction. That's why we use parentheses around these. Same thing over here at 0, negative 8. It changed from a decrease to an increase. That's why we always use parentheses. And then this last example is one where you gotta find the graph. So let's just use our calculator and let's type it in. Now I've already got something in here, so I'm just going to clear it out. Let's type in, even though if you have watched previous videos, you should know how this looks already. You shouldn't recognize that it's a big old U that opens up with a vertex at negative 3, negative 4. So I'm actually going to draw that. I'm not really going to care too much about anything else other than the point of the vertex and the fact that it goes up. That's all I need. I don't care about anything else. Because if you look at it, now you may be wondering, how do I know that point is -3, 4? This is in standard form where it's just x squared shifted to left 3 and down 4. And there's all kinds of ways to think of this. One way, sometimes, if you look at the table, you'll start noticing that you start seeing these y values start to repeat. -3, -3, 0, 0, 5, 5. Well, the point in the middle where they start doing that is a vertex, where it changes direction. That's just one thing. If you know, see that at -3, -4, the y values start to be the same thing over and over again. Another thing you can do, if you hit second trace, this is one that has a minimum at 3 left bound. It's at -3 where we're looking, so I'm just going to type in like -6. And then the right bound, I'm just going to type in like 9. Doesn't really matter, as long as I have the vertex between those two arrows. Then hit enter again. Anytime you see that -2.999999, it's actually a -3. And then the y value is -4. So it's a good thing I looked at it, because it's a -4. Doesn't hurt to double check your work. But in either event, I don't need that. I only need the x value. So it's coming from -infinity to -3. It's going down. And then from -3 to +infinity, it's going up. So it's increasing. I don't know why I put that. -3 to infinity, it's going up. And that's it. So don't be afraid to use your calculator to double check yourself. You may find a mistake just like I did.